Okay, question 4 part 1 is our reduction formula question. So this time we've got the integral of x to the n e to the 2x dx, and we're showing that it's equal to half e to the power of 2 minus a half n e to the n minus 1. So this looks like we're only going to need to do integration by parts once. So we can set the thing we want to integrate, which I call u, lots of people call it v dash, but I go u dash to u and v to v dash. That's going to be my e to the 2x, and then the x to the power of n, because we want it to reduce in power, is going to be what we differentiate. So u is going to be a half of e to the 2x when we integrate e to 2x, and v dash is going to be nx to the power of n take 1. So if we go ahead now and use the integration by parts formula, we're going to get that in is equal to uv, so that's going to be x, or half x to the power of n times e to the 2x, and that needs to be integrated between 1 and 0, minus the integral of uv dash. We've got a constant in our v dash. I'm going to take that outside of the integral straight away, just so that it's not involved in any of this. We don't have to worry about it when we try and deal with what we've got here. So we've got uv dash is going to, I can take the half out as well actually. So half n, and then inside we're going to get x to the n minus 1 e to the 2x dx. So applying the limits to the left term, if x is equal to 1, we're going to get half times 1 times e to the power of 2 times 1. So that's going to be half of e squared. If we take away what we get when we substitute 0 in, we're going to get 0. So that's what we get, because we've got 0 here. 0 to the power of n is going to be 0, so it doesn't matter what we times it by. Over on this side, so we've got our minus a half n. This is now e to the n minus, not e to the, e of n minus 1. If I have minus 1 here, I'm going to have x to the n minus 1, which is exactly what I've got here. So this is I n minus 1. And if I tidy that up, we get what we were asked to show. E of n is a half e squared minus a half n I of n minus 1. That's what we were after.